Hi, everyone. My name is Jason. Over here is Marco. He's going to be helping me out today. And we're going to talk about progressive web apps. So who here is pretty comfortable with JavaScript? And is there anybody who's not comfortable with JavaScript? A couple hands? Okay. So we're not going to get into anything particularly heavy today. But if you do have questions, raise your hand. If I'm not in the middle of teaching, I'll come over and talk to you. If I am, Marco will come and find you. We'll make sure everybody stays with us. So I wanted to start before we get too far and just kind of run through some things that are going to be helpful to know and why this is so important. Who here has heard of progressive web apps? Okay. All right. Has anybody worked with them before? Couple hands? Okay, great. Okay, so one of the questions that I had never really considered before was how much a website costs. And I don't mean in the sense of how much it costs to build it, how much you spend on development or design or hosting, but specifically, how much money do you spend every time you download that website? Typically, when we talk about websites, we'll measure that cost in seconds. It takes 2 seconds to download my website. It takes 10 seconds to download my website. But there's another cost that comes up where you actually end up spending real money. If for someone who's traveling internationally, if you are on a roaming plan and your data is charging you per megabyte, you can spend a huge amount of money for every website that you download. This is somebody who said they spent $7 to download just the conference homepage. That's before they got into the conference program, the schedule, all these things. And the conference, you know, they put them on the hook to have to download all of that stuff, or else they couldn't get their schedule. So mobile data can get extremely expensive. And if you pay by the megabyte or if you've been roaming without an international plan, it can get extremely expensive. In the United States, it costs $2.05 US per megabyte that you use. And that's if you're traveling internationally and haven't bought some kind of extra plan. And websites are getting huge. You can see here that that dotted line is the 2 megabyte mark, which means that as of April 2017, the average website would cost more than $4 US just to download, just to view one page. And so if they don't have a clever caching strategy, every time you click a link, it's $4, $4, $4, and it really runs away. And like this site, for example, this site would cost $10 to download just this one article. Before you load the ads, before you open the read more that loads the rest of the article below the fold, just to view this homepage, it's $10. And beyond that, it just sucks to download a 10 megabyte website on a mobile device. It takes forever. It's janky anyways. You don't need that retina image on a screen this small. So, you know, we want to look at ways to improve this. And it gets even worse. If the connection is flaky, if you're on a train and you're going in and out of reception, or if you're, you know, on the subway in New York or San Francisco, the internet will just cut out. And if you're right in the middle of doing something, you see this screen or a screen similar to it that says, hey, there's no internet connection. But we can fix all of this. We can fix most of these problems, and we can do it without a whole lot of extra work. We don't have to start over. So the solution that we're going to talk about today is what's called progressive web apps. And progressive web apps leverage a browser API called Service Worker. Service Worker is available in all major browsers except for Safari and Edge. Safari and Edge have both started work on it though, so soon it will be available everywhere. So what progressive web apps will let us do is significantly decrease the amount of data transferred on each page load. After an initial page load, we can actually get that amount of data transferred down to 0. You're also able to improve the experience for users on unreliable connections. When you're using a progressive web app, because you don't have to transfer a lot of data, if you're on a low quality connection, most users won't notice. Unless they ask for something that they've never downloaded before, the progressive web app will handle this for them, and they'll never know that they went offline for a while. Now, this does sound a little boring. Okay. But on the you might argue, this isn't my target market. I only target people who are in like steady demographics with good infrastructure, and the people that I work with are only on desktops, or maybe there are a lot of reasons that you can say that this isn't who I'm trying to work for. And it can start to feel, when you hear me talking about progressive web apps and why we should do these things, it can kind of feel like I'm telling you to eat your vegetables. And that obviously is never what you want to hear. It's not that fun. It's good for you, but oh God, why? So, but I honestly think that while you might be asking yourself, can we just ignore this? Can we just maybe not deal with it? You really can't. And there's a really big reason for that. And it's because it doesn't just decrease the load times for a crappy mobile connection. It decreases the load time for all connections. And if you've ever read research from Amazon or any of the big e-commerce platforms, they'll tell you that your conversion rate goes up for every 100 milliseconds that you decrease in your load time. Your conversion rates will go up. So if you can get your load time down to near zero, you don't have that loading penalty where people are getting distracted and walking away. You also get your perceived load times improved. Have you noticed on Facebook, when you first load the page, they show the skeleton component. So it's not actually content. It's a card with blocks of text that are just rectangles before the real content loads. They do things like that to improve the perceived load time. If you just saw a loading spinner, it feels slow. But because you see that box with where text is going to be, it feels fast. It didn't load any faster. PWAs don't actually do that for you, but it opens you up to that pattern very easily. Stability also improves for mobile users everywhere, not just in underserviced areas or out in the mountains, in the city as well. If you go around a corner or walk into a parking garage, your app is still going to work. User experience just gets better all around. Things are going to get a little bit easier to do. So this is definitely more than just an eat your vegetables moment. This is something that's going to make you money. This is something that's going to make your users love using your app and make your clients much, much happier, because the app that they're going to get is extremely performant. They're going to feel like it just flies. So we're going to start by building a simple progressive web app. And I'll give you I should have given you the GitHub thing first, but what we're going to do is register a service worker. We're going to cache the required resources as soon as somebody opens the app, which is called an install. We will serve those cached resources whenever they're available. So they don't ever have, once they download our JavaScript once they download our HTML once, they'll never have to download it again. The cache will do that for us. We're going to fall back to the network if we don't have a resource that is that's in the cache. And once we hit the network, we will cache those responses as well so that we don't have to hit it again. We're also going to add a fallback image in case somebody requests an image that hasn't been loaded while offline. We'll still be able to serve them something. They won't see the little broken box. We'll add a default fallback page. So if they try to request a URL that we haven't loaded, we'll show them something. We won't show them that offline like Chrome dinosaur. We're going to create an app manifest, which on Android phones will allow you to actually install the app to the home page like a regular app. We'll add some app icons so that you can show a splash page, an icon on the home page, things like that. And then we'll add a manifest to the HTML itself. And we're going to do this in 10 quick steps. Before we do any of that, we're going to need to clone this repo. And I will do this along with you. Hide this. Is that easier? Okay. Anybody who doesn't have it downloaded, just give me a hand so I know to wait. Give it another minute. Does anybody need me to hold on? We okay? All right. So next, once we've got the repo, make sure that you're in that folder. So whatever you just cloned, if you're in PWA simple, just make sure you're there. Next, what we're going to do is let's open it in our code editor in Sublime, and we're going to actually register a service worker. Now, we haven't created a service worker yet, but so what we're going to do is go to the index.html, and in here, down at the bottom, we're going to add this script. Can everybody read that, or do you want me to put it on the Sublime screen or on the code editor? And while you're doing that, I'll talk through a little bit about what's happening. So the Service Worker API, because it's not supported everywhere, we need to do a check to make sure it exists. So the first thing we do is we check the Navigator global object for a service worker. If that exists, then we register the service worker, which once we create it will live at service-worker.js. And that gives us a promise. Is anybody not familiar with promises in JavaScript? So the way that a promise works is instead of whenever you do something that is asynchronous, where it has to go out and request something and then get some data back, the way a promise works is that it will go and do that. And once it's done, you get an object called a promise. And a promise will either resolve with the data, which means that it worked and everything happened the way you expected it to, or it will fail and reject. We can use then. Once it resolves, we can do .then and then give it a function to handle the data. So if in this case, we don't need any data, so we just pass it nothing. But if we wanted to, we could take the response and then, say, manipulate that and put it on the screen. Or if something goes wrong, we use catch and catch the error, and we can put something on the screen. Does everybody have... Give me a show of hands if you need more time. Okay. How's everyone doing? You still need more time? All right. So once we've got this, we want to do the first part of our service worker. Now, the first part of our service worker is going to be creating the serviceworker.js file. So let me copy this real quick so that I can work along with you. So I'm going to add this, and then I need to create a new file called serviceworker.js. And inside of that, we're going to add this code. Now, what this code does is it starts, we define a cache version. Now, we have the ability to invalidate this cache at any time. So if we do an update later and we want to make sure that our users get the new version, we can just change this to v2 or to literally anything that's different from what's here now, and the service worker knows to reinstall. So what we're doing is we're saying when somebody opens this service worker for the first time, that's an install command, we catch that event, and then we tell the app to wait until the caches. So we open the cache called sample PWA v1. And then once that's open, again, we get a promise. So we do a .then, and it gives us the actual cache. And we return the result of cache.addAll, which means until you have finished downloading index.html, scripts.js, and styles.css, don't return. That's our way of saying these are the scripts that are required for my progressive web app to work. If these aren't here, the app doesn't work. So what we're doing is basically, it's the same thing that would happen if you downloaded it as plain HTML. Before the browser can render your page, it needs to download the HTML, the JavaScript, and the style sheet. We're just telling it to do that and also put it in a cache so that next time we'll be able to get it out of the cache without having to ask the network. I'll give you another couple minutes to get that. And don't be afraid to ask questions. If some of this doesn't make sense, if I'm speaking too quickly, if you want me to just repeat it, don't hesitate. I am always happy to try to explain a little better. So what this script does is it will fetch those files no matter what. And so what you could do, if you were thinking about this like a game, you could say download the first 3 levels. So you would only use level 1 immediately, but level 2 and 3 would load instantly. And you also have options. We're not doing it here, but there are ways to load in the background so that you could, in addition to these files, load something that you'll need later on, but you don't want to block the page from rendering. That's a little advanced, so we won't do it here, but there's a resource at the end that I can point you to show you those patterns. You had a question? The serviceworker.js. Oh, okay, yes. Oh, wait, you tried to configure which?
No, the language. Because my keyboard was different and I couldn't.
Which one do you need?
I already have it, but on the way I couldn't copy the code.
So you need the one before this? Okay, yeah. So this one goes in the index.html at the bottom. It's this part. Yes. Say again.
Can we use a wildcard, for example?
Unfortunately, no. I will show you a tool though at the end of this that gives you the ability to use, you know, node globs, like where you do like the **/*. There's a tool you can use with Webpack that will do that for you. So that one actually, we'll do that in another couple steps. We'll show how to get like anything that's a JPEG. Marco, if you need to, there's a PWA branch on the repo that you can get stuff that we're like it's the finished piece. Okay. Does anyone still need this screen? Okay. Let's move to the next piece. So the next thing that we're going to do is we're going to set it up to use the cache by default. And so I'll walk through what this code does. When you listen for the fetch event, that's any time that we're making an HTTP request. Is everyone familiar with like the HTTP concepts? Get, post, things like that. So I won't go into detail, but when you make a fetch, you're making a GET request. And we are able to then say, well, catch that. Don't actually send it to the server yet. Before we do that, I want to respond from the caches. So we're catching that event, and then we're saying respond with any cache that matches the request. So if we've already made a request to that URL, it will be in our cache, and then we can return it instead of ever hitting the server. So this allows us to make an app that never needs to hit a server once it's downloaded the first time. So what we're doing is saying caches match any event with that request and then return the data from that cache. The other thing that I forgot to mention is you'll see this starts with self dot. That's a service worker quirk. I don't know why they didn't use this or like service worker or something. It's just kind of an odd thing, but that's something that you'll only see in service workers as far as I've experienced so far. let me catch this real quickly. Does anyone still need time? Okay. So let me copy this in. We can go ahead and start our server here. And let's see, probably the easiest way to do that would be to just open it. Let's see if that gives me what I want. Looks like it doesn't want to do it. Okay, so I think we might have to install a one more dependency, which I apologize for. Go ahead and do an npm install -g for global and HTTP server. It's down at the bottom of my screen there. Oops. Does everyone have it installed? Anyone need more time? Okay. So once you have HTTP server installed, you can just run it. And it's going to give you a URL, which we can click and open in the browser. And I'm running an old version of another web app. So let me clear all this. Am I in the wrong place? Okay. So once you've run that HTTP-server, and you'll be able to open this web address here, what you should see is in your console, let me close the settings so it's a little easier to see. You should see service worker registered. If you don't see that, please put your hand up and we'll come and make sure you're caught up. Does your localhost work? Try, instead of the 127, try localhost port 8080.
8080? Ah, local.
Let's see, the permissions are right.
Permissions.
Yeah, they look right. Let me. You got it? Okay, okay. Okay. Respond with events. Oh, no semicolon there. because it's an argument to another function. This is the part you need? Okay. Anyone else need help? Okay. Try localhost. There we go. Okay. Sometimes it's just the domain names. How's everybody doing? Okay. All right. So let's move ahead here. So the first thing I'm going to show you is on Chrome. It's a little easier to debug. I know if you're using the virtual appliance, you don't have Chrome, but I'm going to show this first. It has Chrome? Oh, I didn't find it. Well, you know. Okay, so on Chrome, you have an application tab in the developer tools, and it will show you your registered service worker. So here, if you want to update it or unregister it, you can click those buttons to do so. And if you need to, as you're developing, you may find that this button is usually helpful, update on reload. Or also, if you just want to make sure that you're all the way set, you can hit this clear storage button. That'll unregister the service workers and clear all the cache storage and everything so that you can be sure that you're starting with a fresh install of your web app. So that'll be somewhere that we want to go. If you're in Firefox, the way the permissions were set up on Firefox in the virtual appliance were a little weird. So I had to go into the preferences and privacy and then tell it to remember history. Once you tell it to remember history, then you can go into, where was it? It was about debugging, and there's a workers tab, and you can see your service workers there. But you have to make sure if you don't have that remember history option checked, then you won't be able to see any of the service workers because of the privacy settings. Oops. Is that it? Nope, that was the wrong one. So privacy, remember history. And then once you've got that setting, you can go to about :debugging. And there will be a workers tab. If you have Chrome, Chrome is definitely a little easier. So now what we're going to do is fall back to the network. So now if we're trying to load something, and I'll show you what I'm talking about. Let me pull this down here. And what we've set up is an app now where if I go offline and try to reload, it fails. And that's because I think I didn't... Did I save the new version? Oops. Save. Here. Okay, so now if I go offline, it still doesn't work. Sweet. Because I probably have update on reload. Is that what it is? Nope. That shouldn't be the case, but that doesn't mean that you're wrong. But that does appear to work, so I must have done something weird. Anyways, so now you can see I'm offline. I have the offline mode set. so that I'm not actually making any requests. You can see when I refresh the page, 0 bytes are transferred. So this is kind of the power of the progressive web app, is that it gives us this ability. However, if I click this button, I'm getting a broken image. And I can see in my network here, I've got a failed request. Now, I don't want that. I don't want a failed request. So the next thing that we're going to do is we're going to add a fallback to the network, because also right now, if I turn off the offline mode, we're catching those requests. So see, I'm actually online now, but I'm still getting a fail. And that's because when I go to this catch here, what I'm saying is only use the cache. So if we don't have it cached from the get-go, we'll never hit the network. So we need to add a fallback to the network. And we do that by making these changes. The lines in red are what's being changed, and the lines in green are what it's changing to. Obviously, you don't need to update the comments. That's just for me. The big change here is that we're adding an OR. That's what this is an OR. So it says, if there's data, return the data, or use fetch, which is a network request, to make a request to the URL that was requested. Then just do a refresh on the page. And then check that service worker again. I think something was just weird because now it's not giving that error. So yeah, try it again offline. There we go. Okay, great. Is everybody all fixed up? We're all good to go? Okay, so now, once we've made this change, let me put it into mine. So now we're going to return cache data if we have it, or we'll hit the network. So let's save that. Let's go back to our progressive web app, and we're going to clear the storage just in case. Let's do a refresh. Okay, so now if I look at the network, I'm going to make this a little smaller so I can actually see things here. We can see that if I reload the page, everything came from the service worker. That's what we want, except this offline.png. Okay. Now, if I click Dance Party, it loads. Okay. So now we're not blocking new information from coming in. It fell back to the network like we wanted. However, we have downloaded this now, but if I've got a few of these, but if I go offline and refresh the page, it's going to always go back to that broken image again. So we need to do a couple more things. Is everybody getting that response? You're getting the image to load when you click the dance party? Okay, great. So now we are going to update this to cache those new responses. So once you've loaded one of those new images, it's going to save it. So what we're doing here is we're going to update, instead of just using fetch, we're going to write a new function called fetch and cache. What this will do is it takes the request and it opens that same cache version that we use for the install, and then puts the fetch request into that cache and returns the response that we got. So effectively what we're doing is saying the first time that we load this, we're going to hit the network, and then we're going to put it in the cache. The second time that we load this, we'll never have to hit the network because now it's in the cache. Does that make sense to everybody? Okay, great. So go ahead and put that in. I'll give you a couple minutes. So this is, and for anybody, I think my slides were a little confusing. The fetch and cache function goes above event.respondWith, and then we only change the fetch to fetch and cache. The rest of it, of event.respondWith, stays the same. Does anybody need me to go back to the fetch and cache function? Does everybody have it? A hand up if you need it. Okay. And then go ahead and make that change. Anyone need more time? Okay. So let's look at how this works. I have put in the fetch and cache function. Let me close this. And we've updated it. Now it's calling the fetch and cache. So I'm going to go ahead and let me make sure my terminal is still running. Go into the application. I'm going to clear the storage again. Refresh. I'm offline, that's why it's not working. Okay, so I'm here. And my service worker is registered. So now if I go to a dance party, let's click another one, okay. Now I'm going to go offline. And so what should happen is I click through here. That one's broken. Let's see what else we got. Nope. Nope. Eventually one of these is going to be the right thing. It requests at random, so sometimes it requests the same one over and over again. Apparently not that random. Although it looks like it didn't update the way that it was supposed to, so let's see what happened here. That's the right thing. Okay, so now these are showing up the way they're supposed to. So I'm going to go offline again. Okay, so now that it's actually doing what it's supposed to, when we are offline and I click on one of these, like this danceoff.gif, that's loading from the service worker, even though we didn't explicitly preload it in the install step. But if I keep clicking through, eventually we'll hit one that we haven't downloaded, so that one doesn't exist, and it gives us a broken image. So the next thing that we want to do is fix that. So, well, actually, before I do that, is everybody getting that response? If you run it, are you seeing that your images are being loaded from the service worker? Question? Okay, so any other questions before we move on? All right, so the next thing we're going to do is we're going to add a fallback in case one of those images is not available, because we don't want every image that's not downloaded to just show that you know, the alt text in Chrome or the little broken box in Internet Explorer or whatever else it might be. So what we're going to do is add a path to an offline image and add that to our install step. And so this is part one. So it's just those two lines. And the reason that I'm declaring it as a constant at the top instead of just putting it in the list, we're going to use it in multiple places. So in the future, if this image were to change, we only have to change the path once rather than having to find everywhere that it was used. Does anyone need me to hold on? Are we all there? Anyone? All good? Okay. So once we've got that added, now we need to reference it when there's not an image. So in the fallback, what we're going to do is, in addition to when we respond, we now have an error condition. So again, we talked about promises a little bit. The cache will return a promise. And what we're saying is, when you get data from the request, either return that data or get it from the network. However, if there is no cache data and we're offline, that fetch and cache is going to throw an error, which will be caught by the promise, and then we can use .catch to add error handling. And so what we're going to do here is we're going to create a new URL out of the request so that we can do some pattern matching. If the URL ends in .gif, then we know it's an image. For this application, that's all we need. For a more complex application, you would need to do matching for JPEG, PNG, all the other image formats. And this could also be different as well. For example, if you have avatars and article images, those are going to be two different sizes, so you wouldn't want to return the same image for both. You would need more logic here. But for this purpose, this is the simplest example. So we're matching to make sure that if any image that we haven't loaded yet is not available, we're going to return this offline image as a placeholder. Good? Okay. All right, so let's see how this works, and then we'll take a break. So I'm going to go back into the application. I'm going to clear my storage, go back to the network, make sure I'm online, and I'm going to refresh. Okay, so my service worker registered like I wanted it to, and if I download an image, it shows up. Let's refresh the page, and we can see everything's coming from the service worker. So do another one of those. Now let's go offline. And when you go to click through, you'll see the image. So dancing in public here did not load, but we fell back to our offline image. And if we click through some more of these, eventually we'll get back to one that's cached. So here, if the image exists, it still loads. So we're able in this way to kind of not break our app's experience. We can just let the user know, hey, you're in offline mode. We don't have all the data. So, you're still seeing something. It's not a broken experience, but you'll need to go back online to get the full experience. It's a way to kind of control that situation. Is anybody not getting that? Ooh, lots of hands. Okay. And for anybody who is getting it, feel free to start your break early, and we'll see you back at 11:15. Okay. Is anybody not running? Okay, so yours is still down. Mark, do you want to do that? Okay. So the next thing that we want to do here is right now we have the images falling back, but if I'm offline, so if I go offline here and I try to pull this up, that's fine. But if I try to go somewhere else, I just get the site can't be reached, right? So as kind of a last resort, what we want to do is add the ability to just kind of catch any requests that we don't understand and send them somewhere else. So what we're going to do is add a default fallback page. So just like the offline image, what we're going to do is declare a constant for where that page is. And then we're going to add it to our install step so that it gets put as part of the Progressive Web Apps core code. Does anyone need more time? No? Okay. So once we've added the offline page as part of our install step, we can now add just kind of our last-ditch fallback to put this into the page. And we'll put this down at the bottom. So in our catch block, we're just going to go after the URL match. We just want to put that in there. And so what we're saying here is if something goes wrong with the load, basically if we're offline and we don't have it cached, check if it's a GIF file. If so, return our fallback image. If not, return our fallback page. And we're making a pretty broad assumption here that the only thing somebody would request that's not an image is another page. In an actual application, you'd probably have multiple fallbacks for if somebody's loading an article, if somebody's loading a API request, anything that somebody could be requesting, you probably want to have a specific fallback for that case. Because our app only does one thing, it just shows these images, we don't need a lot of fallbacks. Does anyone need more time? Okay. So once we've got this in place, now what we can do, if I get in here and let's clear the storage and refresh the page. So we get installed here. Things are working the way that I expect them to. Great. So I'll go offline and I get what I want, get in my fallback image, and now let's try to go somewhere else. If I just go to a different page on my site, instead of seeing that ugly network error, now I get this fallback screen. Now remember, that is in our files as offline.html, but we're serving it under elsewhere.html, or really anything other than index.html. It'll always return this offline page. And so this is another way that we can control our experience. When somebody is using our app, we never show system errors. We only show our errors. And that puts a burden on us because we need to make sure that we're providing helpful errors. If this was my app and the only error message anyone ever got was this page, that would not be a helpful experience. I would rather have default system errors at that point. But if I have different things that say, hey, you'll need to go online to save this type of file, or without an internet connection, we can't download your latest friend requests or messages or whatever. All of those things let somebody know, hey, things are behaving the way that they're supposed to, but you need an internet connection to do that. It helps us kind of control and simplify things. And again, looking at the index, another thing that's just super important to keep in mind here, we're still transferring 0 bytes on every request here. And that's with, we're getting the HTML, we're downloading our offline page, any of the GIFs that we have cached, which I don't know if we have any right now because I don't think I did that. Yeah, I don't think we do. But any of the GIFs that are loaded, they don't require any additional bytes to be transferred. So once somebody gets this once, if we set up our caching properly and give them the experience that they want, we're able to completely keep them offline. They could download this once and then go into a nuclear bunker and never see the outside world again, and our app would continue to work for them. So it's a really powerful way to consider how we can do things. If you're building a conference app where, say the Wi-Fi wasn't working here, if the conference app was a progressive web app, the schedule could be downloaded offline. So you could get it once at home, come to the conference app. You don't even need to connect to the Wi-Fi. You can load up your schedule, you can do things, save things, make sure that you know where you're going without ever needing to connect to the internet. So there's a lot of really good opportunities to consider how this is going to work. But also just keep in mind, even when we're online, this just loads very fast. When we don't get a lag of waiting for it to connect to the browser. We don't have, I'm connected to the internet right now. I'm online with the cache disabled, so it should be downloading everything fresh. And still, we're transferring 0 bytes. So the whole page loads in just a few. We've got full load in under 500 milliseconds. And that's from hitting refresh. That's really, really fast in terms of what people perceive. It's fast enough that you're definitely not going to be hurting your conversion rate. And when you get to more complex pages, sites that have multiple screens and views, those view switches are going to happen very, very, very fast. So the last thing that we need to do is we want to start looking at setting up an app manifest. Now, an app manifest is not strictly required. What this does is it allows someone to install your app on an Android home screen as if it were a regular app. So in the event of, say, the Web Summer Camp website, if they install this as a progressive web app and add this manifest, you would then be able to not only load the site once and then continue to use it, you could install it as an app on your home screen, click the Web Summer Camp icon, and have your schedule. So it would be just like installing a regular app without actually having to go to the App Store. And while this doesn't work on Apple yet, they have announced that they plan to support it. So work has started on progressive web apps. Within the next, hopefully, couple of years, you will also be able to install a website as an app on both Android and Apple devices, which is going to be huge for the internet. When that changes, it's going to create a whole new industry. Making sites like this is going to be an extraordinarily valuable skill, because if you can get around the app review process for Apple, if you can get around the hassle of having to force somebody to go to the App Store to update your app, sharing revenue with Apple, for example, for every app that you sell or every in-app purchase that you make, you now have a higher profit percentage, you have better control over your app, and you have no barrier to entry for building it. You don't have to hire a web developer, Android developer, and Swift developer to build an app. You just build one web app. It works on the internet, it works on Android, it works on Apple. You've got everything covered, with the exception of Windows Phone. But they're also working on progressive web apps, so that won't matter for them either. They'll also be able to just install it on their phone as an app. So this is the app part. So what you want to do is create a file in the root called manifest.json. That is going to live right here. And inside of it, we're going to put this code. Let me close this so you can see. And so there are a few things happening here. The first thing is we're setting a name. The name is what would show in the title bar. The short name is what will be used on the home screen. And you only get about 12 characters on the home screen, because otherwise it'll truncate. It'll give you the ... So you have to be a little clever in how you name things to make sure that they will fit on that home screen. We then specify the start URL. So in our case, it's going to be the index.html. You get a choice of display mode. There are 2 display modes. There's browser mode, which when you open the app, it's just going to look like the browser. And then there's standalone mode. When you open a progressive web app in standalone mode, it's going to hide the URL bar. It's going to hide the built-in sharing controls and things like that. It expects that your app is completely set up to operate on its own with no additional controls from the browser. In our app's case, that's fine. We don't have any navigation or anything that you need to do other than click that dance party button. So we can do that as a standalone app. The background color, when you first open the app, they will show what's called a splash screen. and it's just going to be a blank screen. So by default, this can look kind of broken. But they give you some control over this. So we can set a background color and also an icon, which we'll do in another step here. And the background color will be shown as, instead of a white screen, maybe you show a blue screen. And then the icon will show in the middle of it, so it kind of looks like a typical app loading screen, which is, you can use a GIF if you want so that it spins or does whatever. And then finally, the theme color. The theme color will control what what color the title bar is. If you're looking at it in the browser, and you go into the window view where it'll show all the tabs you have open, it'll control what color the URL bar is. So if you set it to like a purple color, then everybody else's app that doesn't have a manifest will just have the standard white bar, I think it is, but yours will be purple. It stands out. It's easier to spot. So it gives you a little more control over what's going on. Now, once you've saved this, we can then add our icons. So the next step is to add these icons to the bottom of this manifest. So down here, I'm going to add these. And so I just add a comma at the top, and then get rid of all this. And so I already created these icons. The 512 by 512 size icon is the one that's used for the splash screen. So this is the one that will load when you first install the app or when you open the app from the home screen. The 192 will be downsampled to use everywhere. It'll be used as the favicon. It'll be used as the app home screen icon. It will be used pretty much anywhere else that they're going to display an icon for your app. The 192 image is the one that will be used. Give me a hand if you need more time. Everybody's good? Okay. So now that we've got our manifest set up, we just need to reference it in our HTML. And we also have to set that theme color again. This is kind of I don't know that I fully disagree or that I fully agree with this approach, but the theme color meta tag is used by the Android when it's a browser. The theme color in the manifest is used when it's installed as an app. I don't know why they don't just use the same value, but for now you have to add both. And the other thing you have to do is just add this link, call it, give it a relationship of manifest, and set the path. And you're just going to add this up into the head of your HTML. So we'll just add it here. All right, does anybody need more time? All right, so we can validate this really easily. Once it's set, we can go back into this application tab and just click the manifest. And once it loads, we can see it shows up, it tells us where it is, it'll give us the identity, so it shows us the name and the short name, and then shows us what we're doing. So everything that we wanted is in here. We can optionally specify the orientation. If you wanted to, you could force your app to be in portrait or landscape mode. If you don't need to do that, I'd recommend not doing it. Let your users do what they want. And then we have our icons. So in our case, I used the Web Summer Camp logo. And we now have a manifest set up and running. And so that's it. At this point, we've got a fully functional progressive web app. Is anyone not seeing their manifest showing up in the application tab? If you haven't seen it yet, try a hard refresh first to make sure that that you've got the latest version. Now, something that we can do to validate whether or not a progressive web app is doing what it's expected to do. In Chrome, there's a plugin called Lighthouse. I don't expect anybody to do this right now, but it's something that you can use. I have a link to it at the end of the slideshow, which it sounds like there's a Slack that Evo created that we can join and share links on. I'll also tweet a link to the slides so that you can get a link to it. So if you follow me on Twitter or if you just watch the WebSC hashtag, I'll make sure to tweet the links to the slides so you can get the resources. But when you use Lighthouse, what it'll do is it will go through and create a report about your progressive web app, letting you know whether or not you're meeting what Google considers to be best practices for progressive web apps. And so it loads a few things. It does your mobile responsiveness. It does whether or not you're handling offline. It'll check, all sorts of things here. Now, the one that we're going to fail because we're doing local mode is that we're not doing HTTPS. However, I have this one live. Let's see here. So here's our app again. Let's generate it from an HTTPS server. And as it runs the analysis, once we get to the end here, you see we've got 100%. So we've got everything that we wanted. We passed all, there's 11 audits that they run. So they want to make sure that there's a service worker, that it works offline, that JavaScript isn't required to see anything. You got to expose a little bit of content even if JavaScript is disabled. It's served over secure traffic, or it's served over HTTPS. Also, if you're not using SSL certificates, there's a free way to get them from Let's Encrypt. If you're curious about that, there's a whole different talk, but just send me a message on Twitter, and I can link you to a way to get free SSL certificates. And this is a big deal because Chrome has started to give people errors, like it shows them that your site is not secure if it's not over SSL. So if you're not doing that already, tweet at me. I'll send you to a link. It's a walkthrough tutorial to get it for free. Your page load, they want to make sure that somebody on a slow phone can get the site quickly. They want to make sure that you can install it as a web app. And then the settings for that kind of stuff, the splash screen colors, the theme colors, and then some mobile stuff. The meta name viewport is so that you can set the size on a phone to make sure that it scales properly. And when you load that, they want to make sure that you're not blowing the content way off the side when you load it on a phone. A couple of the things that they verify, which are just nice, is your performance. They'll tell you how long it takes to get to content, how responsive your content is, whether or not somebody would see like input latency, which is once they click, how long does it take for it to respond. And so here they're telling me that I should inline the style sheet. So instead of loading styles.css, just copy paste that right into the head. You can do that manually with just by copy pasting, or you can use something like Webpack to do it. That's kind of minutia. Like, worry about the rest of this stuff first, and then get into the micro optimizations. They do a few other things, like they check accessibility, which is really important to start checking. Google is going to start degrading sites for poor accessibility, so make sure you're passing those checks. And then they've just got a couple other like general best practices. None of these are things that you have to do. They're just things that Google in general says, like, hey, the experience is going to be better for people if you do this. Does anybody have questions on Lighthouse? No? Okay. I would highly encourage you, download this plugin. It's just called Lighthouse. It's a Chrome extension. It's free. Run it on one of your sites and just see how you're shaping up on this. The stuff that we did today, you can more or less copy paste the vast majority of what we did into any website and get a pretty decent response. You'll need to work on the offline handling, and you'll need to make sure that you update the scripts that you're caching so that the app works. But for the most part, a lot of the script is just copy paste. You can move across, get it running, boost your score, and vastly improve the websites that you're working on.
Getting errors that respond with didn't receive a request or response after.
Do you have? Fetch and cache returns the response from fetch. So it makes a fetch to the server, and then it will respond with whatever comes back after putting it in the cache.
Now I get it. So it returns the promise from then, right?
Yes. And so that would resolve this then, which we can catch if there's a problem. And if you wanted to, you could change this to an error and console log that error to see if anything is coming out. So there are some ways to debug that if you need to. So what we'll do with the remaining, I think we've got about an hour, is we're going to look at some tools that'll do this for us. So we just wrote all this by hand to kind of get our heads around what is a service worker, what is it doing under the hood, why is it important, and what are the benefits that it can give us. Google, of course, being the giant tech company that they are, has more or less solved this problem for us. So we're going to use a tool called SW Precache so that we don't have to write this from scratch. So this is an app that, this one should be part of the virtual appliance. It's called the PWA Workshop Starter. And we're going to, let me switch over to that one. Don't save. And let me make sure. Okay. So this one, when we run it, is a little more involved. It clear my storage. Now what this one does is it gives us this one actually has a start script, so let's figure out what that is. We need to run npm run serve, and that will give us our, there we go. So this one is a slightly more in-depth app where we are loading a bunch of images. We've got tabs so that you can look at different types of images. And we have an about page. And so you can see here, even on the local network, you can kind of see this lag. When I click, there's a delay, and then things kind of have to load in. So there's a lot going on here. And if you click on one of these images, it's going to open, and you can view it. So we want to make this into a progressive web app. Let me make sure. So I've already got this one running as a progressive web app, which means I need to undo some things. No, I don't.
I think the project is called JS
Which one?
JS
For,
Everyone using the virtual appliance.
they have it under JS Perf? Oh, okay. It's under JS Perf. So I would run npm run serve, and that will start the server for you. And if that gives you an error, run npm run build first. So those are the commands there so that you can get it built and running. Yeah, you do need to clear the application cache once you get started. Make sure that you're running without the service worker. So clear storage, get rid of everything, and then when you go back to the service worker, when you reload, there shouldn't be one. I don't know why it shows as deleted. Whoa, that was the wrong button. Okay. So you should be seeing no service worker in your dev tools once you get it up and running. You,
So that I just switched from root to how to run
npm run build.
yeah.
Okay, so we're already in there. And so by default, this is an older screenshot of Lighthouse. It doesn't really look that way anymore. But by default, this app does not score particularly well as a progressive web app. It misses a lot of the audits. It's kind of slow. It has to download a lot of images. And as a result, we get a pretty low score. So our goal here is to improve that. And so we're going to register a service worker so that we can do the caching, get the offline access, all those things that we need. We're going to create an app manifest, make sure that the service worker knows which assets are required, cache, define rules to cache everything that's not required to run the app, and then we'll also do lazy loading, and we're not going to do the offload. We're not going to have time for that. So let's. It sounds like a lot of work. We just went through the process. We just spent 2.5 hours building a simple progressive web app. So looking at something more complex like this, it might seem like a whole lot of work. But again, Google already did most of the work for us. So we're going to install this SW Precache Webpack plugin. Now, I actually think this is already installed in the system. I think if you look in your node modules, you should see it. The node modules are always huge, but check to see if you've got the SW Precache Webpack plugin so that you don't have to wait for an npm install on the conference Wi-Fi. If you don't have it, run that install command. Does anybody? Is anybody who's looking at the appliance? Is it already installed? Okay, good. Okay. So once we get it installed, we're going to basically take advantage of everything it does for us. The Webpack plugin, it'll create the service worker for us. We just feed it a file. This is the glob syntax I was talking about. We can feed it kind of a wildcard that says, hey, any files matching these patterns we want you to add as dependencies, and any files matching these patterns we want you to cache on their download. We can also use, like I said, URL patterns, and this will enable the offline access for us. So all we need to do to make this work is add a configuration object to Webpack. Who here has not used Webpack before? Okay, a couple hands. It can look super daunting the first time that you've used it. We're using it in the simplest possible way, and most of it's pre-configured. Just put your hand up if you need help, because it can be a little hairy the first time you use it. So go ahead and open, let me just copy paste this into the Webpack where it needs to be. So webpack.config.js, if you look, at the bottom here, all the way on line 27, there's a plugin section. And what we're going to do is just put this config into that plugin section. I'm going to zoom out a little bit so we can see it. Can everybody read that? Is that too small? Okay. So I'm going to talk through what this does, and then I'll give you some time to actually copy it. There's a lot going on here, so I'd encourage you to pay attention. What we do is we specify where the service worker should live. Now, because what we're doing is taking a source folder and building it to a distribution folder, that dist, we're going to put the service worker in the root of the folder, or of the public files, which is our dist folder. Something that is really important to keep in mind about service workers, they can only access things that are in the same scope or deeper than them. So if you put a service worker at example.com/blog, it can't do anything for example.com. It can only do things for example.com/blog or /blog/article. It has to be scoped at the lowest possible level. So typically speaking, you would want your service worker to be available at example.com/serviceworker.js. And that's what putting it in the distribution folder right at the bottom That's what we're doing, is we're putting it at the very root of our public files. Runtime caching is what the SW precache is calling anything that doesn't need to be pre-cached. It's stuff that when we load it during the runtime, which is why they call it runtime caching, you want to put it into the cache. The handler, they give you options. You can do network first, cache then network, cache only, network only. So you can specify, for example, if you're loading images, you probably want cache first. If you're loading a data file, you would probably want network only, or you would want network first. So if you're offline, get the whatever the most recently downloaded version was. But if you're online, you want the current version. So you'd always want to hit the network. So that lets you control how you get that data. Static file globs is the install step, stuff that is going to be required for every load. And now this is where we get a little bit fancy. We're using node glob syntax. So if you've ever used Node, this is it's patterns that match. It's called globby. It's a very common Node module that probably is installed in just about every Node module you've ever installed before. Depends on globby. It's either globby or minimatch, and they're basically the same. But what we're doing here is we're saying either CSS or JS files. So it'll match dist/assets/css/main or /js/main. And then the same here. It'll match .css or .js. And then here, what we're saying is in the assets folder, anything in this folder, so the star means anything, that ends in either .html, .png, .xml, .ico, or .svg. So it's kind of a clever way of just matching a wide range of files. And so the reason that we're doing the PNG, the XML, the ICO, I'll show you in a second. We're going to use another tool that will help us generate our manifest.json really fast. And then finally, because this does get served locally, or it gets served on the internet, we're going to drop this dist folder prefix. So it's when we go to the website, it's not mysite.com/dist/index.html. You just serve that dist folder. So it's mysite.com/index.html. So we need to let the SW precache know that we're not using the dist folder. We're actually serving the dist folder. So we strip out that prefix. Does anybody have questions on how that works? Okay. I'll give you another minute or so to get that copied. Remember, put your hand up if you've got questions. Webpack can get a little hairy. How are we doing? Anyone need more time? All right. So once we've configured, we are going to, again, register the service worker. Now this is more or less the same thing that we did in the simple one. In our index.html, and in this case, because we've got two files, we've got index and about.html, we need to register the service worker in both. Now, if you were doing a real application, you would probably want to put this into your build process to copy this snippet into every view. Because I didn't want to overcomplicate things, I didn't do any templating. So you're just going to have to copy paste. So if you want to take this script and let's put it into index.html all the way down at the bottom. And then we'll also put it into about.html all the way at the bottom. This is all on my GitHub. It's the PWA workshop starter. And if you need to see the working code, go to the PWA branch. So once we are done there, we're going to generate a manifest. Now, we're going to do this the fast way. So realfavicon generator.net is a tool that will just do this work for us. So in the root of, oh, are you going to do it? This might not work because of the internet. If it doesn't, we'll cheat and check out the branch. So here we have a nice, let's see. We'll take this big one. And so we can open this. I clicked the button too many times. So what this is going to do for us is basically it'll build our whole manifest for us. So we can see here, you know, here's what the icon will look like. Here's what it'll look like here. They give you options if you want. You can add a solid color or, you know, things like that. We're just going to kind of let it be. You can control this. If you want, you can upload a custom image for Windows to make it look a little better. I'm not going to bother in this case, but you do have options. And is this going to load? I'm not even going to bother with that part. If you have an SVG icon, this is a little bit easier because it'll kind of like do the outline versions for you and all that good stuff. If you want to try it with an SVG icon, the Web Summer Camp logo is an SVG, so you can go to their website and download it and then use that in the favicon generator to see the full output. So you can see in this case, it's not going to look great in Safari because we're using a PNG. They also have a bunch of options for, like, you can do a version if you want to change the version. You can update the compression to do like high compression, low quality, or high quality, low compression. They'll give you options for the scaling algorithm, which this is kind of helpful to see how your image looks at really small sizes. And you can choose the one that makes your image look best. I don't know if it's going to load for me, so I might not bother. And then the app name, we can set directly. So we'll set it to WebSC PWA. And I'm going to keep my fingers crossed that the internet holds up for me. It may not. Hey, it worked. So what this will give us is, in addition to a manifest, it'll also set us up with like all of the shortcut icons that we would need for adding a favicon in the tab, setting like a window, you know, the Windows icon that we defined in there, the Mac OS pin tab kind of stuff. So it does more than just give us a manifest, but it gives us the manifest for free, which is great. So I'm going to download this favicon package, and I'm going to copy this. And now into my index and about.html. Looks like I've already set all of these here, so I'll just delete these and we'll add them again. And so you can see here kind of what that looks like. And then, to make sure that everything is actually present, we have to open this folder and then move that into our source folder. And so I actually already have all this done, so I'm not going to copy it over. But so we've got everything here, what we want, and we're able to the source folder. Sorry, let me. It's in the yeah. So in the SRC folder, you'll just put them right in the root. So they should be right there. And I will copy these over, actually. And so the real favicon generator, it's completely optional. You don't need to use it. You can build your manifest by hand like we did in the other one. The benefit of using this one is it'll resize the images the way that we need them resized and does some other optimizations for us. But again, it's a nice to have, not a must have. I'm looking at the fastest way to get this done. And so SW precache plus this real favicon generator means two tools that do 90% of the work for us. Once we do that, we just want to check the manifest to make sure that it's got the short name, which by default, they don't put a short name in. So I just copy the short name over. And once we've got that, we're basically ready to go. Okay. So once we're set here, then we can open the terminal again, and we're going to stop serving it. And so we'll do npm run build again. And this regenerates all the files, copies them over to our dist folder. This will also build the service worker. And we'll get a warning here. This is a warning that we don't care about because we did manage for this. The custom path, that's putting it into the /dist folder. But because we're stripping out the prefix, that's not a problem. Typically speaking, they would put it right in the root. But again, we're not doing it that way. So once we do the npm run build, we can now do npm run serve. And that's going to put our site up for us. And if I do a reload, I get my service worker. Okay, so everything is running. And we can see here on the network, when I load, the images themselves are being downloaded. Some of them are from the service worker, some of them are coming from the network. If I reload again, everything is coming in from the service worker now, which is what I want. And what that means for me is I'm going to go to index so that I don't get the error. And then I go to about. And everything is coming from where I want it to come from. So now let's go ahead and go offline. And it's not working because why? Yeah, the disabled cache shouldn't be a problem, but doesn't mean. Let's see. Does it do it? Still not working. What did I do wrong? Let's see here. take a look at the service worker that gets generated and see what's going on. So if I look in here, I can see what SW precache generates is pretty gnarly. And it looks here like they didn't set up the cache the way I wanted, which means I probably did something wrong. It's because it's not the assets folder. That is my fault, everyone. I typoed. The dist, it should just be dist, not dist/assets. I apologize. So if everybody wants to fix their Webpack config, and then do the npm run build and serve again, that should solve that problem. This is the line that we're fixing. Remove /assets from the line that loads HTML. Okay, so now that I've fixed that, when we look at the service worker, we should see, let's check, that's much better. Now we actually have our file. So the about, our different real favicon generator images, the touch icons, and the things that they generated, as well as our assets for the JavaScript and CSS. So now, if I npm run serve, and refresh. Let's clear the storage and do that again. Okay, we're installing, and now I should see all coming from the service worker. That's what I want. So let's go offline and try this again. Hey, there we go. So now notice I cleared my cache. Let's do that one more time. Let me completely clear this service worker. I'm going to clear it. It's totally gone. And I have just reinstalled it. Now notice I have not gone to the about.html page, right? I haven't loaded it, so it shouldn't be available if I was offline, but because we installed it as part of the install step, we can actually visit the whole site. Now, what we didn't do was get these images because I disabled the service worker and re-enabled it after they loaded the first time so they didn't get caught by the cache. If I refresh that page again and then go offline, now when I go back and forth, they're available. And it got the ones in the background. So this is what we wanted. The only thing that we haven't downloaded now are these large images. And now I did not set a fallback image. We would have to go in and edit the service worker to do that, which if this was something we were going to take live, we would do. But the cache policy is there that if I go online and click and then go offline again, this one's still missing, but this one will come back for me. Even if I go over to the about and then back over, I still have that image. So it's set up to kind of cache as things are used. This is a way for us to, when we've got a large amount of data, like in this case, we don't want to download all of these images. This would be multiple megabytes of data. It's a waste of our users' money. They don't need to download that many megabytes if they're not using them. So we only have them download things when it's time to use them. Yeah, go ahead. Is something missing on yours? Your name is empty. So you want to put in a name and a short name? Okay. So we've got about 25 minutes left. This is really the bulk of what we wanted to cover. How's everybody feeling? If you want to give me like a thumbs up, thumbs to the side, thumbs down. You don't have to give me a thumbs up just because I'm looking at you. So the last thing that we can do is as kind of a bonus, I'll show you a script that I use to get even things a little bit faster. There's a script that we have called, it's one that I wrote, and it's called lazy load. And what this one does is it will, let's see here. You know, I might not want to, we might get a little heavy. I'm worried that I don't have enough time to finish this, actually. I'll tell you what, if anybody's interested in learning this, it's probably more than 20 minutes worth. So you'll probably need to grab me. I will be here for the rest of the conference. So, you know, if you want to talk about anything related to this workshop, or if you want to talk about anything JavaScript or front-end performance related in general, bring your computer over, let's sit down, we can talk. I really enjoy talking about this stuff, and I don't want to, I don't think I have enough time to explain this well, so I think I'll leave you feeling lost if I try. So I actually think, does anyone have questions? Because otherwise I think I'll probably just call it here, where we've all got running apps before introducing some complexity. Go ahead.
Once you turn the browser off and start it up again and run it in offline mode,
Uh-huh.
you see the page again.
Yes, yeah. Let me show you. I'll just turn off my Wi-Fi, and I'll.
Turn off Chrome and then
Yeah.
restart.
Yeah. So let me copy this. I'm gonna quit Chrome altogether, and then I will restart it, and we're gonna see. You get the app back. So this is like I said, it's a way to keep your app available basically until they clear their cache. So obviously, if somebody hard refreshes on this page now that I'm off the internet, it'll break. But I think if I regular refresh again, it comes back. So until they actually clear their storage and their cache, it should be available. The only downside to this approach is if you cache aggressively, you have to have strategies in place to bust that cache. Webpack will do this for you. Webpack will give you what are called cache busting hashes, so that when you generate your, say, scripts.js, it'll do scripts.somehash.js. There are a lot of patterns that are ready-made to do this for you, so that you don't need to figure out how to do it on your own. I would recommend kind of learning the general concept, but you don't need to reinvent that wheel. You know, typically I prefer on my own. I want to write it by hand to learn how it works. In production, I'm going to let somebody else do it. Any other questions?
Yeah, for example, if I have a blogging software or blogging site,
Yes.
then the blog post will still be in the cache, right?
It depends. So there are a couple ways that you could do this. One would be when somebody loads a blog post, you can put it in the cache. That's how my blog works. So if you've never visited the page, it won't be available. But if you have visited it, up to like the most recent 10, I think, will stay in your cache.
So if it's not exactly a blog, but like a stream of messages.
Yes.
If I am a user and posting message and I'm offline, what would be the best approach to store or cache the blog post until I'm online again?
If you wanted to write offline.
Yeah.
So
Getting a message, you're offline.
yes.
Be sent as soon as you're online.
So there are a lot of ways to approach that. The one that I've found to be the most straightforward is to use an offline database like PouchDB and a database like CouchDB on the server side. Because what they will do is they will actually in real-time sync. So if you are if you're writing offline, it'll store anything that the user is doing on their local storage. And then as soon as they connect again, it will sync that to the server. And it'll automatically resolve conflicts. Like if you edit a document while you're offline and someone else edits that document while they're offline, it'll do its best to merge those changes. If it can't merge the changes, unfortunately, the most recent one will win and you'll just see an issue. Or I think you can write extra handling where if it was super important, you could just say, hey, we can't merge these, split them into two documents and then let them manually merge them themselves. There are other ways you could do it where you could potentially like write that to a text file in their cache and then read it out. That's a lot of work. I would recommend probably using something like there's a framework called Hoodie that uses Pouch and Couch that will solve a lot of these problems for you. There's another database called crap. What is it called? I'll have to tweet it because I can't remember what it is off the top of my head. But it's specifically designed for the same like offline online editing. Or you could use something like React with Redux. Redux has offline persistent storage, so any edits that are made to the Redux store can then be dehydrated and saved to the local cache, and then rehydrated and synced to the remote server when you get a connection back. So there are a lot of ways to approach that, but
I'd like to follow up on this Redux thing, because our company we're using React with Redux,
yes.
and we're having light usability issues because Redux is just, persistent for the current page load.
Right.
You go to the next page and the Redux stores below, right?
Mm-hmm.
And this offline persistence thing, is it like a Redux plugin or an extra feature? How do I...
Yes, it's a, what is it called? It's a Redux plugin that's called Redux Persist, I think is the most popular one. There are several approaches, but they all, like, there are different flavors of doing it. So you could even, in theory, use Redux with PouchDB. And so instead of having Redux write to a remote server, it would write to the local one, and that would just sync in the background. So there are a lot of ways that you could approach that. The easiest one I found is the Pouch plus Couch. Any other questions? Okay. So we're about 20 minutes early, but I'll let you guys get out for lunch. Like I said, come and find me. I'm always happy to talk about this stuff. I'd love to sit down and talk through any other concepts you have. Also, I will be tweeting some resources. I have on the, let me get back to the slides. There's some resources here that you can use. Like I said, I'll tweet these. At the top left, Jake Archibald is on the, I believe he's on the Chrome developer team. He has written a cookbook of different patterns for offline, for using service workers. So, you know, cache first, cache only, network only, all the different combinations that you might need. He's already written those patterns. They're copy pastable. Lighthouse is the plugin that you can use in Chrome. SW Precache is the Google tool. SW Precache Webpack plugin is the like Webpack wrapper around SW Precache. The favicon generator is that tool that'll build your icons and everything. And then responsive lazyload.js is a helper that I wrote that I didn't have time to show you, but effectively it allows you to have your images only load when they're visible in the viewport. And it's kind of mostly a copy paste. You have to do some find and replace on your images themselves. And then the PouchDB is for offline database support if you want to do that. And I can show you, let's see, I think it's, this is an offline first database that it runs, this is Couch and Pouch. So this one will run offline. And if anybody wants to visit this URL, actually, you can play with it at the same time. And what you do is you can save, you know, anything, and pull it up and edit it, all the things that you would want. But if I go offline, it continues to work. And then if somebody else is looking at this app, you wouldn't see this change yet. But you'd still be able to edit, make any changes, all those things. And then when I go back online, it will take these changes, push them to the server, pull anything that was made. I don't know if anybody changed anything while I was talking, but these changes are all done in real time. So I'm not refreshing the browser. If anybody's got this live and posts something, they'll sync up while we're talking. But that source code is also available online if you want to look at it. It's on my GitHub as offline first DB example. I can tweet all of that. Again, you know, I'm showing a lot of stuff here. Some of it's only sort of related to progressive web apps. So come grab me if you want to talk more about it. I'll happily show you source code, walk you through how it works. But I don't want to, you know, I didn't want to overload this too much. Anyways, thank you all so much. I appreciate you coming. Enjoy the rest of the conference.